All right, so this is a homework problem where we had three consecutive even negative integers, and the sum of their squares needs to come out to be 5,300. So, give me a pitfall you might have. What are the numbers?
Well, x squared.
Now, what are the numbers? What are what we're looking for? Even, negative. What are the integers? Okay. So, what's the first integer? What's the first integer?
X squared.
No.
Negative x parentheses.
What's the first integer? X. How about x? When I write x, is x a positive or negative number?
Negative. It's
Both.
Let me think. If I'm thinking of a number, I'm going to call it x. Am I thinking of a positive number? You don't know.
It can even be imaginary.
Exactly. So you don't know whether when I write x, you don't know whether it's a positive number, a negative number, or an imaginary number, or a complex number, or who knows. So just writing x by itself doesn't mean anything. And if I write negative x, is that a positive number or a negative number? You don't know. So don't hurt yourself by putting in unnecessary things. Just call it x. And you expect it to be a negative number in the end, right? What's the next? You don't want to do something cumbersome. You want to keep it easy. So what's the next consecutive even negative number if x is the first one?
X plus 2.
All right, we'll go with x plus 2. And the next one?
X plus 4.
X plus 4. Are you going to agree? Those would be three consecutive even numbers. And if they happen to be negative, that's great. All right, so what's our equation going to be?
X squared.
X squared plus
Parentheses x plus 2.
the second number squared
Quantity squared.
plus the third number squared equals 5,300. Perfect. This is looking good. All right, so we're going to FOIL it out. So what do we get?
3x
X squared plus
squared.
x squared
Plus 4x
plus 4x plus 4 plus x squared plus 8x plus 16 equals 5,300. Looking fine?
Yep.
All right, we're going to simplify it. 3x squared, I agree with you,
12x
plus 12x plus 20 equals 5,300. That was digestible. Okay. So 3x squared plus 12x
minus
5,280 equals 0. Right? No. We could pull out the quadratic formula. We could whip it off and say we're done. But this is still a little effort to try to do some factoring. So what's the first thing we would do in factoring?
No, wait, it's different.
What's the first thing we do in factoring?
Oh, discriminant.
First step is always
finding the sum.
what is common.
What is common?
Right. What is common?
12 no 3.
3. So we can pull out a 3. And we'll have 3x squared plus 4x minus, looks like 1, with a remainder of, excuse me, what do you get? 1, 7, sorry about that, 1760. Great. Equals 0. So next thing we do, well, why don't we divide both sides by 3? So we really just are looking at this. And we could have just done divide both sides by 3 up here. That would have been fine to go directly from this step to this step because that's really pulling out the common multiple. All right, so now we could again use the quadratic formula.
No,
But we can also factor, I bet. Let's look at 1760.
Oh, you can divide them.
1760, so it's 10 times 176, which is 2 times 5 times, wow,
Oh,
any ideas?
44.
42 times 8.
4
44.
and 44, great. Just a good grab, he saw it. 76 is divisible by 4, therefore this number is divisible by 4. So we have 2 and 2,
2 and 22. 11,
2 and, well, you're right.
Just do 4.
Why don't we just do a triple? 2, 2, 11, right, why not? So, now here's where it gets interesting. Here's where you have to use your brain. This 1760 is negative. So the signs are going to be positive and negative, right? In order to get x squared, I have to have an x and an x. Now, when you think about 1760, it's a pretty big number when you compare it with little 4, right? So the number that is here and the number that is here don't differ by very much. They only differ by 4. All right. So I would bet that the numbers we're looking for are very close to the square root of 1760. So when I look at the factors, I want to create numbers which are really close to each other. They're only going to be 4 apart. Okay? So there's some art in doing that. I don't know whether they're going to be lucky enough to think about it, but this is 44 all by itself. What are all the other factors? 2 times 2 times 2 is...
6.
No, 2 times 2 is 4, times 2 is 8, times 5 is 40. Wow, here's 44, and if I pool all this stuff, I get 40. Well, there it is. That's what we want, right?
Is it always work like that? It's actually
Well, that's a little logic with how close to the square root are we? See, I'm just doing some playing, and whatever I don't use in one factor, I have to use in the other. And I'm shopping until I get factors which differ by 4. And I was lucky that it came out my first try. If it didn't come out first try, I'd try some more. All right, and we'll actually talk about how we might factor even if we're not that lucky. So, the pluses win, so this must be 44. And the negatives are not as powerful, this must be the 40. And so x equals negative 44, right? Or 40. But we're not interested in the positive ones. We know our answer has to be negative. So we're just going to draw a nice thin line through this. We're not crossing it out. It's great work. If we're looking for positive results, we would want this one. But the thing we're looking for is negative. So there's x. We're also looking for x plus 2 and x plus 4. So if that's x, x plus 2 equals negative 42. And if we add 4, we get the negative 40. Okay? That's it. All right. I got enough time?